Hello everyone, welcome to another video of Cloud Deep Dive. Before we start our today's video, I want to thank all our viewers for their support. And if you are new to our channel and haven't subscribed yet, please go ahead and subscribe to our channel and click on the bell icon to get the latest updates. I'm releasing a new video every week on AWS Cloud Services, so it will help you out to get those updates and you will be notified whenever a new video is released. So without wasting any time further, let's start with our today's topic. Okay guys, our today's video is Route 53 Private Hosted Zone. Before you start learning about private hosted zone, I will recommend you guys to watch my earlier video Domain Name System, where I explained in detail that how a domain is converted or resolved to an IP address, what all steps it takes, what all servers it goes, and how it find out the exact IP address to which you can connect and get the example.com domain. So this is prerequisite for this Route 53 video. If you understand how the whole system works, it will be easy for you to understand the Route 53 hosted zones as well. So assuming that you understand how the domain resolution work. So what happened that whenever you create a Route 53 hosted zone, what it does that it internally associate or allocate you four different namespace servers. We call it NS server, and internally it create a zone file. Zone file is nothing but a set of records which has a set of records like if you create a record or CNAME or any other record, MX record. So this zone file will have all those records for your domain. In this case, like example.com, it's having a record saying that if any request come for the example.com, then convert it to an IP address of 1.2.3.4. And what it does, it copies the zone file into this NS server. So each NS server has a copy of your zone file, and whenever a request comes from your registered registrar for example.com, it comes to NS server, and NS server will locate your hosted zone file, and from the zone file it will find out which record they are looking and give the IP address to them. So if we go to our previous slide, and if you watch that video, what happened that when you type the example.com, it goes to your DNS root name server from where you get the NS record for your .com. You go to .com server, NS server, where you get the NS record information for your example.com. And when you reach to Route 53 for that particular NS server, that NS server will have the zone file like we discussed here, and that zone file will give you the IP address of your example.com, and that IP address will be returned to you. From there you will reach to that IP address and get your web page. Next, let's see what happened that when your EC2 instance tried to reach to a domain name, what path it takes. So first, from your EC2 instance, your request for the DNS resolution goes to VPC plus 2, which is .2 address of your VPC router. It goes there. From there, it goes to Route 53 resolver. Now, Route 53 resolver, try to resolve it from three different places. One is your private DNS, which is your hosted zones. It try to resolve it from that. If your domain name exists in that private hosted zone, it will get the IP address from there and give it back to you. If it is not there, then next is go to Amazon domains. If it is there, then it will try to resolve it from there and give you the IP address. If not, then it will go to the public DNS. So it will follow the same order which I'm showing here, first to the private hosted zones, then the Amazon domains, and then the public DNS. So if you create any private hosted zone with the dot address, that means that superpower everything, that request will always go to private DNS and will try to resolve there, and it will never go to Amazon domains and public DNS because dot is superpower or kind of highest level of your domain. Next, let's just talk about the same architecture. How what happened that if you have a private hosted zone, you got a zone file where you put a record of example.com should be converted to this IP address, and this zone file is placed on all these NS servers. Now, in the private hosted zone, you have to associate your zone, private hosted zone with the VPC. And the same thing happened that whenever EC2 instance make a request, it goes to dot to address, and from dot to address it goes to route 53 resolver, and the very first thing it goes and check that for the private hosted zone. And if you find that example.com which is trying to resolve, if there is a zone file in there, then it will give you the IP address of that. But if there is any record which is not associated with the hosted zone, private hosted zone, then it will block that request and it will take the next Amazon domains and the DNS, uh, public DNS route, so it won't resolve it. Next, let's go to our console and see that how you can create a private hosted zone, and how you can what all NS records you will get once you create it, and how you can create a record, and how your EC2 instance will resolve to this IP address from the private hosted zone. Okay guys, I've logged in into my AWS console and will go to Route 53, which you can find under all services, network and content delivery, and Route 53. In that Route 53, you can see you have a lot of options, and we will be talking about hosted zones today. So let's click on hosted zones and we'll click create hosted zone. So you can create two type of hosted zone. One is public and one is private. So today we will be talking about private hosted zone. Let's give an example here. Suppose I want to resolve example.com from my internal VPCs. And like I mentioned that you have to associate your private hosted zone with a VPC as well. So I will select my US East 1 region, and then I'll select my default VPC in that. And we can click on, if you want to give in tags, you can give that and click on create hosted zone. So once you create a hosted zone, like I mentioned, you will get 4 NS servers addresses. So these are the server address where your zone file is copied, and one SOA record. Now another thing what you need to do, you have to create a record in that. And a record is basically uh, kind of converting. It says that if any request come from example for example.com, then convert it to an IP address. Similarly, you can create another records as well. Like if you say a record for a records, it's mapping your example.com with the IPv6 address. Like a record is with IPv4 address, and a 4A record is IPv6 address. Next, you have CNAME. CNAME is basically if you're mapping one domain name with another domain name. MX is for mail server. TXT record is if you want to specify some text, and that is used when your domain verification need to be required. So sometimes the uh, registrars give you a TXT record and ask you to put that same verbiage or that recording value in your domain name and to verify, and so on. So having this information about these reports is important if you're going with advanced specialty networking course. So just read about these and get little familiarity that which CNAME and A record and TXT record where they are used. So for this we'll use the A record. And to simplify the demo, what I have done that I have created a web server. It's just a EC2 machine, and I don't have any public IP address to it because we are creating a private hosted zone. So I'll use that IP address, private IP address, and we'll put it here. So what will happen that from another EC2 machine from our Cloud9 environment, I'll try to do a DNS registration for example.com, and when I do it, it will give me the IP address of this. So internally what will happen that let's first create this record. And so internally what will happen that when this EC2 machine try to resolve the example.com, it will go to .2 address. .2 address will send the request to route 53 resolver, and route 53 resolver will send that request to your private DNS. And because this VPC is being associated with this hosted zone which I stated, it will find the NS record, NS server, and from the NS server it will get the zone file. From the zone file we have already have example.com which is pointing to this particular IP address, so it will provide the IP address and send it back to your machine. So let's go to our Cloud9 environment, and if we do dig example.com. So you can see you got an IP address of 172.31.36.194, which is the IP address of your EC2 machine. So internally it did the same thing what I told you, that it went to .2 address, from there it went to Route 53 resolver, from the Route 53 resolver it went to your um, private hosted zone, and from there to NS record, NS server. NS server got the zone file, from there you got the A record, and you got the this value. So it will cache this value for 300 seconds. Another thing to remember in that, whenever you create a record, you have to give a time to live. Time to live is basically for another 5 minutes. If that um, EC2 machine again make a request, so it won't go through the whole path again. It will just cache this IP address for 300 seconds, and once the 300 seconds are passed, and then it will go and make the another request and try to find out the another value. So time to live is for how many seconds it will cache this IP address at the calling or whatever EC2 instance, try to resolve it, and after that it will come back and do it again. So if suppose I change that A record and put some other IP address, it won't affect, or it won't resolve to that new IP address immediately. It will take 5 minutes, and after 5 minutes it will start resolving to a different IP. So that's it for today's video, guys, and if you have any question, please feel free to put a comment and I'll be happy to answer your questions. And please don't forget to subscribe to our channel and like and share this video. Thank you so much, guys, for watching.